The most catastrophic engineering failures ever. Let's start with the ones that should have been prevented and work our way towards the ones that absolutely, definitely, 100% should have been prevented. Number 8. The Dee Bridge Collapse, England, 1847. The Dee Bridge was a cast-iron girder bridge spanning the River Dee in Chester, England. It was designed by Robert Stephenson, one of the most respected engineers of his era, a man who, by all accounts, knew exactly what he was doing. Except for this one time. The bridge had been open for 2 years without incident. Trains crossed it daily. Nobody was concerned, nobody was asking questions. The bridge was fine. Then, on May 24th, 1847, a passenger train crossed the bridge and the whole thing snapped. The girder fractured, the train derailed, and 5 people were killed. The subsequent investigation revealed that the cast-iron girders had been reinforced with wrought iron tension rods, which sounds sensible until you understand that the combination of the two metals under load caused a twisting force that cast iron is spectacularly bad at handling. The Dee Bridge collapse became one of the first major engineering disasters of the railway age. It triggered a formal government inquiry into bridge design. It changed the way engineers thought about materials under load. And Robert Stephenson, for his part, never fully accepted that the design was at fault. Some things never change. Number 7. The Quebec Bridge Collapse, Canada, 1907. If the Dee Bridge was a warning, the Quebec Bridge was what happens when you don't listen to the warning. The Quebec Bridge was being built to span the St. Lawrence River in Canada and was set to become the longest cantilever bridge in the world, an enormous, ambitious, record-breaking project. It was also being built over budget, behind schedule, and with a chief engineer who was managing the project from his office in New York rather than the construction site in Quebec. Warning signs appeared early. Workers on the ground noticed that some of the steel members were bending under the load. They reported it. The reports were reviewed. The conclusion, reached from a comfortable distance, was that the bending was within acceptable limits. It was not. On August 29, 1907, the south arm of the bridge collapsed into the St. Lawrence River. It took less than 15 seconds. 75 workers were killed. Most of them Mohawk iron workers from the Kanawake community who had traveled to the site for work. A royal commission investigated and found that the design was fundamentally flawed, that the warnings had been real, and that the decision to continue construction despite them was catastrophic. Then, because apparently one collapse was not enough, the replacement bridge being constructed on the same site partially collapsed in 1916, killing 13 more workers. The Quebec Bridge finally opened in 1919. 12 years, 2 collapses, and 88 deaths after construction began. Number 6. The Malpasset Dam Failure, France, 1959. The Malpasset Dam sat in a narrow gorge in the south of France. It was a thin arch dam, an elegant, slender structure that worked by transferring the water pressure outward into the valley walls, rather than relying purely on the dam's own weight. The theory was sound. The execution had one problem: the rock. The geological survey of the site had identified the valley walls as solid and stable. What it had missed was a hidden fault line running through the left abutment, the section of rock the dam was leaning against to stay upright. On December 2, 1959, after a period of heavy rain that had raised the reservoir to its maximum capacity for the first time, the left abutment gave way. The dam didn't crack. It didn't gradually crumble. It simply ceased to exist. The wall of water that followed was over 40 meters high. It traveled at 70 kilometers per hour down the valley, wiping out the town of Fréjus and everything between the dam and the Mediterranean Sea. 423 people were killed. The disaster happened so fast that most of them had no warning at all. The Malpasset Dam remains one of the deadliest dam failures in European history. The ruins of the dam still sit in the gorge today, largely as they fell, as a permanent reminder that the ground beneath an engineering project matters just as much as the structure above it. Number 5. The Ronan Point Collapse, England, 1968. Ronan Point was a 22-story residential tower block in East London. It was built using a construction method called large panel system building, where prefabricated concrete panels were stacked and connected to form the structure. The method was fast, it was cheap, it was extremely popular in post-war Britain, where thousands of tower blocks were being thrown up to address a housing shortage. It was also, as it turned out, dangerously reliant on every panel staying exactly where it was supposed to be. On May 16, 1968, a resident on the 18th floor turned on her gas stove. There was a leak she didn't know about. The gas had accumulated overnight. The explosion blew out the load-bearing wall panel of her flat. Without that panel, the floors above had nothing to stand on. They collapsed downward, and the impact of each falling floor knocked out the panels below it, creating a progressive collapse that peeled an entire corner of the building off from top to bottom. 4 people were killed and 17 were injured. Given that the building housed hundreds of residents, the death toll was lower than it could have been, largely because the explosion happened at 5:45 in the morning, when most people were asleep in rooms away from the collapse. The investigation revealed that the connections between the panels were held together with what was essentially a thin layer of mortar and optimism. Ronan Point was eventually demolished in 1986. The investigation of the rubble found that the bolts connecting the panels had never even been properly tightened. Number 4. The Hyatt Regency Walkway Collapse, United States, 1981. Of all the entries on this list, the Hyatt Regency collapse is perhaps the most straightforward example of a single, avoidable mistake turning a normal Friday evening into a catastrophe. The Hyatt Regency Hotel in Kansas City had a spectacular atrium lobby with 2 suspended walkways crossing above it at the 2nd and 4th floor levels. They were a design feature. People loved them. On the evening of July 17, 1981, hundreds of guests were gathered in the lobby for a tea dance competition. The walkways were full of people watching from above. During construction, the original walkway design had been modified. The change seemed minor, a small adjustment to how the hanger rods connected the walkways to the ceiling. An engineer approved it over the phone without reviewing the load calculations. The modification had quietly doubled the load on the connection point of the 4th floor walkway. At 7:05 p.m., the connection failed. The 4th floor walkway fell directly onto the 2nd floor walkway below it. Both collapsed into the lobby, onto the crowd beneath them. 114 people were killed. 2,170 people were in the atrium at the time. It remains the deadliest structural collapse in United States history that was not caused by a natural disaster or deliberate act. The engineer who approved the change over the phone lost his license. The change itself had taken less than a minute to approve. Number 3. The Vajont Dam Disaster, Italy, 1963. The Vajont Dam was, by almost every engineering measure, a triumph. When it was completed in 1961, it was the 3rd tallest dam in the world. A stunning double-arch concrete structure rising 262 meters above the valley floor in the Italian Alps. The dam itself never failed. That is the most important thing to understand about the Vajont disaster. The dam was fine. It held. It did exactly what it was designed to do. The problem was the mountain. Geologists had identified that Monte Toc, the mountain rising above the reservoir, was unstable. There was evidence of ancient landslide scarring on its face. Surveys had flagged the risk. Engineers had noticed that the hillside was slowly creeping toward the reservoir as the water level rose. There were meetings, there were reports. The decision was made to continue operating the dam and manage the water level carefully to keep the mountain stable. On October 9, 1963, 260 million cubic meters of rock, soil, and forest slid off Monte Toc and into the reservoir in approximately 45 seconds. The displacement of water created a wave 250 meters high that surged over the top of the dam and down into the valley below. The towns of Longarone, Pirago, Revolta, Villanova, and Fayet were destroyed in minutes. Around 2,000 people were killed. The dam still stands in the valley today. It will never be used again. The landslide debris still fills the reservoir behind it, a permanent geological record of one night in October 1963. Number 2. The Tacoma Narrows Bridge Collapse, United States, 1940. The Tacoma Narrows Bridge collapsed just 4 months after it opened. It had been nicknamed Galloping Gertie almost immediately after opening because it had a tendency to sway and undulate in the wind in a way that was, at minimum, deeply concerning. Engineers were aware of it. The movement was monitored. The general consensus was that it was unusual but probably fine. It was not fine. On November 7, 1940, winds of around 40 miles per hour began hitting the bridge. This was not an extreme weather event. 40 miles per hour is a stiff breeze. But the shape of the bridge deck, flat and wide like a ribbon, caught the wind in a way that created a phenomenon called aeroelastic flutter, a feedback loop where the wind-induced movement reinforced itself, growing larger and larger with each oscillation. Within hours, the bridge was twisting violently. A car was abandoned on the bridge by its driver, who could no longer walk across the deck. The only other casualty was a dog left in the car, which is genuinely one of the saddest footnotes in engineering history. The bridge collapsed into the Puget Sound. No human fatalities. But the Tacoma Narrows collapse fundamentally changed how bridges are designed. Number 1. The Banqiao Dam Failure, China, 1975. Everything before this entry has been a tragedy. This one is a different category entirely. The Banqiao Dam was one of a series of dams built on the Ru River in Henan Province, China during the 1950s. It was designed by Soviet engineers, built quickly, and was considered so solid that it was nicknamed the Iron Dam. In August of 1975, Typhoon Nina made landfall over China. It was an extraordinary storm, the result of a cold front trapping a typhoon over the same location for days. In just 24 hours, the Banqiao catchment area received over a year's worth of rainfall. The dam's drainage sluices had been closed to prevent a flooding situation downstream. They could not be reopened in time. At 1 a.m. on August 8, 1975, the Banqiao Dam failed. The wave that followed was 10 kilometers wide and between 3 and 7 meters high. It traveled at 50 kilometers per hour. Within hours, 62 dams in the region had failed in a chain reaction. Around 85,000 people died directly from the flooding. In the months that followed, disease and famine caused by the destruction of crops and infrastructure killed an estimated further 145,000 people. The total death toll is estimated at around 170,000 people, though some estimates go significantly higher. For decades, the disaster was classified information inside China. The rest of the world did not learn the full scale of what had happened until the 1990s. The Banqiao Dam failure is the deadliest structural engineering disaster in recorded human history, and it was caused, in the end, by a drainage sluice that could not be opened.